My name is Corbin Hawk, and I will be talking about the Hydra Mini Fridge Dispenser and the Design Phase 2 presentation on behalf of Team 31. After discussing multiple product ideas, we decided to work on a mini fridge drink dispenser. This will be an insert that will replace the use of 2-liter bottles in a mini fridge. This is supposed to be a compact system that college students could use in their dorm room, offices could use in their mini fridges, or hotels could use in their mini fridges. Our ideal customer is a college student. So we have created a customer profile and a use case based on the college student. Our product is for clean, organized people who always want to have a cold drink available or want to store drinks for gatherings in which they might want to dispense liquid more easily. Our use case is in which a customer replaces the drink in the dispenser. We are assuming in this use case that you just have to change out the 2-liter bottles. So the user basically removes the product from the fridge, changes out the old bottle, and puts in a new bottle, and then replaces the whole system back into the fridge. This is supposed to be a simple yet effective design. Our customer research produced needs and specifications. So we found customer statements, which was raw data based off of products that customers currently were using, such as Brita filters and Brita faucets and Brita pitchers. So based on these customer statements and raw data, we found interpreted needs such as the fact that our dispenser needs to be easy to clean, compact, and quick to set up. These needs were then interpreted and we used to create specifications such as height, length, width, time to clean, and time to set up. The functional decomposition broke the product concept into its core components. So as you can see in our chart here, the energy from the source is stored. Then with a signal, the stored energy turns on a dispenser which opens a valve. Stored fluid is dispensed into a cup or whatever a user is dispensing into, and the dispensing of the liquid does not stop until the user inputs information again, turning off the dispenser and closing the valve. This is the concept combination table that our team created. The team identified solutions for the product subfunctions. So these subfunctions include receiving user input, the dispensement style, opening and closing the valve, storing energy, storing liquid, and dispensing liquid. Here we have the solutions and the specific examples that can fill these subfunctions. The circled subfunctions are the subfunctions that our team found to be the most important subfunctions. These are the most important because the other three were determined to not change in our design. It was more reasonable to use a gravity method for dispensing our liquid. It was more reliable and reasonable and practical to put a battery into our dispenser because it has to go into the fridge, and opening and closing the valve, you have to use a motor either way. So the most important subfunctions were our receiving user input, dispensement style, and storing the liquid, because these are the subfunctions that would change when creating different designs for our product. We used the 3-2-1 method to quickly generate designs for each of our team members. So these are the first two designs that some of our team members came up with. Both of these designs use a vertical model and use 2-liter bottles to contain the liquid. The 3-2 model helped us to question whether we wanted bottles or boxes to store the liquid in our dispenser. The vertical design helped our team to question whether the container should be vertical or horizontal, and you can see where we question this in the side margins around our designs where we questioned whether it should be rectangle or whether it should be vertical or not. And so this design aspect helped us to question these design aspects. Similar ideas were created by team members during the 3-2-1 method. Both of these designs use 2-liter bottles and a slanted method of gravity for allowing the liquid to leave the container. These designs show a difference in using a tube for dispensing the liquid and using a spout on the front of a flat surface for the dispenser. These are the last two designs created using the 3-2-1 method. These are two creative ideas that didn't quite match the others. Here we have a box that would be filled with liquid with a lid and a shelf on the side to create more storage. And here we have two 2-liter bottles linked together which would hold a larger amount of liquid. Important aspects of these designs is that the spout should be at the bottom to help with the gravity method. So this is the mind map that our team created. Mind mapping helped our team to organize the design components of the dispenser. The larger white bubbles on the outside are the main functions or needs of our hydro dispenser, and the smaller branches off of those are ways to fulfill those needs. For example, user-friendly, we need a user-friendly user interface, and the user interface can be a button, a switch, a knob, or a trigger. After gathering all of this information and narrowing our concept combination table, the gallery method gave us feedback from fellow college students. So these are the 6 designs we came up with based on our 3 important subfunctions of dispensing method, method of storage, and dispensement style. And you can see how those were implemented in the designs above. It was found from feedback based on our fellow college students that it is important to easily see the amount of liquid left in our dispenser, that not all bottles can fit that college students might want to use in our dispenser, and that it's really important for this dispenser to be easy to clean, and a bag would not be easy to clean. Our solution concepts were screened using the switch bottle tube design as a standard. So that is this SBT. The BBT was not much different, and that was the button bottle tube. So the only difference here was that this had a switch and this had a button. So those two both had zeros all the way throughout. The 3 that moved on from this concept selection is the knob box spout, the switch bottle tube, and the button bottle tube. The double bottle design, which was the BBN, and the bag designs, which was the KBS, were too complex and deemed unmarketable compared to the standards of SBT and the BBT. Each criteria was given a weight. Our volume was given a 20% with the highest weight, and after that our dimensions had the next highest weight of 15% each. The team determined that the aesthetics were the least important weight. The bottles were found to be harder to clean, attach, and involved more risk of spillage when assembling. They also couldn't dispense the liquid fully, lowering their scores and putting both box designs in the lead. So KXS and SXN were in the lead. KXS won by a small percentage because of the aesthetics of a knob and a spout being higher than a switch and a nozzle. Finally, the team determined that the knob box spout would be the best product design. A combination of input from the gallery method and concept selection tables led to the choice in this design. The box was found to be the easiest to clean and easiest for fitting into a fridge while holding the largest volume possible. The box would also look more clean than soda bottle inserts sitting in a mini fridge. This product design fits our identified customer needs and follows our mission statement of creating a simplistic and competitive model. Thank you for listening.